Here is the third example that we could use to solve this line integral using the Green's theorem. Now, one thing to remember is that when you apply the Green's theorem, you should have a closed curve. You should have a closed curve, and the vector field should be in two-dimensional plane. Okay, now if you apply the Green's theorem, we can convert this line integral into an area integral. So using the Green's theorem, we get this line integral equals to a double integral over the region D, and here you should get partial q over partial x minus partial p over partial y dA. And what is your p? P is the first part of the vector field, q is the second part of the vector field. And if you evaluate these two partial derivatives, you will get partial q over partial x. So derivative of this one with respect to the x variable should be 3x squared minus, by the way, derivative of this y cubed with respect to the x variable is 0. So we do not get a contribution from this part, minus partial p over partial y. Derivative of 2x cubed with respect to the y variable is 0, and derivative of minus y cubed with respect to the y variable is negative 3y squared dA. Now if you simplify the integrand, you will get 3x squared plus 3y squared dA. Now what is your domain D? Domain D is the region that lies inside the unit circle. So we have a unit circle. It is a circle with radius 1. So let's say this is x squared plus y squared equals to 1. Okay. Your region D is this part. That's your region D. So as you can see, it is easy to use the polar coordinate system to solve this integral. If you factor out 3, you have 3 times x squared plus y squared. That's your integrand. Okay, now in polar coordinate system, x squared plus y squared becomes r squared, and the area element dA is r dr d theta. Now r goes from 0 to 1. So r goes from 0 to 1, and theta goes from 0 to 2 pi. Okay, let's evaluate this. So you have integral from 0 to 2 pi, integral from 0 to 1 of 3 times r cubed dr d theta. If you integrate 3r cubed with respect to the r variable, you will get 3r to the power 4 over 4. Apply the upper limit and then the lower limit. You will get 3/4. We can pull out 3/4 from the integral because it's a constant. Now we have integral of 1 d theta. Integral of 1 with respect to the theta variable is theta. Lower limit is 0, upper limit is 2 pi. If you apply the upper limit, you will get 3/4 times 2 pi, which is 3 pi over 2. So sometimes if we have a closed curve, it is very easy to use the Green's theorem to evaluate a line integral.